that is coming in that direction, the asteroid is, let us assume, the asteroid is coming that thing, the force which they have to come in the opposite direction. So that is what it tells that it could not come in the back, so two particles should act in the opposite direction. So that tells the negative. That is if AB is equal to, both the forces are equal, the force that is acting on this particle and the force that is acting on this particle are same, all the same, but it should come in the opposite direction, then only it will collide. So that is a similar way what we see that elastic and inelastic collision, something like. Now friction. Friction is a type of corrosion, not corrosion, a type of collision like that. Okay, friction. When the friction will arise, friction is the one by which the two particles can, what you will tell it? No, friction is. No, not collision. Collision is that collision is different. That is a head-on collision. Okay, friction is what? Rubbing, like rubbing. Yeah, correct. Rubbing. That is two particles rubbed each other. Is that relates to friction. So that in that it's called a static friction, and one is a kinetic friction. Static friction is the one at the rest. Rest means there is no friction at all. Okay. I am keeping to hand. Will you get any friction? No. Now I am rubbing the hand. So now I will get the friction. When I will get the friction? When the no. When I will get the friction now? When two particles move each other. When two particles or two objects, you can take as two objects. Okay. When two objects move together, you will get the static kinetic friction. Now I am coming here, static friction. I am keeping the two objects closer. Okay. What is the friction now? No friction, because it is not moved. So it's a that is a static friction. Now we go for the circular motion. Circular motion is you can go to the Guindy race, you can take some ground, okay, driving, okay, driving, you can take the circular path, okay, circular path you can take, take some circular path and take some circular path, okay. So take in the car, you can make some circular path and learn the driving process, okay. Driving process something. So in the circular path, what you have taken is the force acting on it is the mv square by r, that is Fc, and so the centripetal force is greater than the static friction. So if every static friction is there, means what whether the total kinetic energy that is moving of in the circular path Vs is equal to Rg tan theta, okay, and tan theta. So tan theta whole root of tan theta, that is so Vs is equal to Vs is equal to Rg tan theta. So if I increase the speed, that is Vs is the velocity of the particle. So if I increase the speed of the if I increase the speed, which will have the higher speed? You go for a circular motion, okay. Go for a circular motion, take the car and thing. Yeah, I am increasing the radius, okay. I am increasing the radius. one is a shorter radius, other one is a longer radius. Okay, so which will irrespective of the radius, what will happen? The speed of the thing, what will the speed of the car? Speed of the car will be speed of the car is irrespective of the radius. Okay, but when I given more turns, what it tells that the speed of the car will decreases. So the speed will decreases if the curve is more. So it's given by Vs is equal to Rg tan theta whole root. Okay.